Okay, so the reason that all of this stuff is important with these integrals is, we can probably look at a very basic line and say, what is the acceleration, what is the velocity, just from logic. But if we have like a crazy formula for acceleration, which includes, like, you have, if you have force is equal to mass times acceleration, getting into physics, but you're like subtracting like a coefficient of friction from the wind or something like that, you have some crazy acceleration formula, which comes out to like mu k times t, or like friction times t squared or some crazy thing. You can't actually, you have to do the integral of that. So what you would have is you would have like t squared plus 2y minus 4 is the acceleration, and it's a function of both time and elevation, where y is like the y-axis and the x-axis. So you have like a plane that's flying, and it's the acceleration is based on time, because the engine is for whatever reason, I don't know why it's based on time. We're just making up a formula, okay? And then it's also based on elevation. So what we're saying is, as you get higher, the air pressure is lower, so you go faster. And then for whatever reason, as time goes on, the engine just keeps getting stronger and stronger as time goes on. And so you just have like infinite acceleration if you just keep going. That's not how a real engine works, but we're going to pretend that it is. So what this is now is, this is Calc 2, two-dimensional calculus, where you have both the time dimension and you have the elevation dimension. So what you have to do is you have to integrate with respect to time. You also integrate with respect to y. So you have acceleration. So you have dv dt, which is change in velocity with respect to time. You also have change in velocity with respect to elevation. Okay, so you have now an equation that has multiple variables. So what you have to do is you have to integrate with respect to both. Right. So you have t squared dy plus 2y dy. So t squared dy is the same as t squared times 1 dy. And as you remember, 1 dy is y. So what we have is t squared y plus y squared, where this is y squared over 2. And then you have the negative 4, where you have minus 4y. So this is the first half. And now we also have to integrate with respect to t. So t squared over 3 with respect to t, or t squared is, so you're going to get t to the third over 3, because what you're doing is you're saying you're doing t squared dt, and then you're doing 2y dt integral, and you're adding all of this together. So we're like adding this like vertically. So we're taking the integral with respect to t and y of all of this. So you have t squared y plus y squared minus 4, and then you're adding in the t to the third over 3 because you're integrating t squared dy. So we add the dt and we add the dt. So we're integrating and we add a second integral, we add a second integral. So the integral of 2y dt is 2yt. And the integral of negative 4 dt is negative 4t. Right? So the reality is we can't actually just do it this way, okay? But what I'm doing is I'm demonstrating how the integral works. So if you can integrate a variable of y with dy dx dt dx, right? Oops, t. So you can integrate y with something that's not y. and you just have y tx. Right? But it's not quite that simple. So what we had before is we know that velocity is equal to acceleration times time plus initial velocity. But where does this initial velocity come from? Because if you integrate acceleration dt, it's just at. So where's this initial velocity? So every time we integrate, we have to add a constant. So in reality, the integral of a dt is at plus a constant. Right? So if I have integral of something simple, we're going to say y dt dx, and then we're going t and we're going x. So what we do is we first start with t. So we have y times t plus c. And now we still have to integrate x. So we have yxt plus cx. But what if we integrated x first? If we integrated x first, we'd have yx plus c, and then we'd have yxt plus ct. So our answer is changing based on what we integrate first. So here we have a constant times x, and here we have a constant times t, but we haven't broken any of the rules of integration. So which is the correct answer? Is it yxt plus ct, or